Hello everyone, today is day 26 of solving a LeetCode problem every day. And today we're going to be solving linked list cycle. And just quick heads up, I haven't solved this problem yet, so let's just go ahead and work this one out together. So given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. Return true if there's a cycle in the linked list. Otherwise, return false. So, let's see. So, it's telling us that there's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. So what this basically means is a linked list has a cycle if you can keep traversing this linked list and eventually you land on some node that you've already have passed before. So basically in this case, you restart, or you don't restart, but from -4, this node's next node is 2. However, 2 comes before -4. It's already in the linked list. So that's how we know that it's a cycle. Um, the next thing it's saying is internally, position is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. So I guess they're not passing this in as a parameter into the function, so we don't actually know what this position is. So I'm not exactly sure why that's even there. Maybe it's just maybe they're just giving it in test cases to just kind of show us like what's going on. Like it's saying position 1 so that the node that's repeated is at position 1, which is 2. So I mean, that's what I'm assuming that's for. Then it's telling us to just return true if there's a cycle in the linked list. Otherwise, return false. So now the question is how can we solve this problem? So first of all, we gotta start out with figuring out what exactly we are trying to solve here. We're trying to solve if there's a cycle in the linked list. And how do we know if there's a cycle in the linked list? We know there's a cycle in the linked list if some node's next node is a node that we have already traversed through. So basically there's two parts of this solution. First of all, we have to traverse the linked list, and then second of all, we have to find a way to keep track of nodes that we have already traversed or nodes that we have already passed. So what I mean by this is we have to traverse the linked list, but in the same time, we have to keep track of these nodes that we are passing, because at some point we may reach a node and that next node is some node that we've already passed. So we want to make sure, or we want to know when that happens. So that's basically why we want to keep track of the nodes. Yeah, so we just want to return if there is a cycle or not. So in this case, there's no cycle because there's no cycle on the linked list. So cool. So first of all, traversing the linked list, I mean, this is the easy part. We've probably all done this a million times already. We want to create a pointer to the head and then just say while current is equal to current.next. So I mean, if I print this out just in case anyone would like to see, let's do current.value just so we can print out value. Okay, I just realized something. This is actually, maybe it will, but since there's a cycle in the test case, this is just going to keep running forever. And the reason why is because, so we get to -4, -4.next is 2, then 2.next is 0, 0.next is -4, then you go back again and you loop again. So this is why it took so long and output limit exceeded, because it's going to go on forever. It's never going to stop. because there's a cycle in the list. So, I mean, but I made my point. So this is how we're traversing the linked list. Next. So I guess the second question is how can we store the elements that we have already seen? And the way we can do this is, I think we can do this the best way to do this might be by using a set. So let's call this list set maybe. And we're going to initialize this as a set. And what we're going to do is we're going to check if current is in list set. And basically what this means, if the current node that we're at is in the list set, then it means we've already seen the node. So in this case, we can return true. Otherwise, what we want to do, if the current node is not in the list set, we want to say list set dot add current node. So we're going to add the current node to the list set. So I mean, another point I want to make is when we're like these nodes themselves, like when I say current dot next, it refers to a pointer for the node. So even though we might have two nodes that are the same value, it's not going to say that the current node is in the list set because they have different references. So if I can print it out again, but if I just remove all this really quickly, just current is equal to current dot next, and we say print current, and I run this. I mean, it's going to take a while just because of what we said earlier. Oh, found cycle. I don't know what's going on here, but the point I'm trying to make is each node, like head.next is like current.next is going to refer to another node, and that node is going to be a reference. So they're all going to be unique. But anyways, if I just command Z, cool, we're back here. So if the current node is not already in the list set, we return, if the current node is in the list set, we return true, because we know we've already passed this node. Otherwise, we want to add that node to the list set, and we want to continue traversing. Otherwise, if we leave this loop right here, it means that a cycle doesn't exist, because we already went over this. If a cycle exists within the linked list, this is going to go on forever. But if we eventually exit this while loop, then it means it has to not include a cycle. So let's try running this. And yeah, so this should be all it is to the question. Yeah. So the time complexity of this is going to be O of n. So it's going to be linear, and the reason why it's linear is because at most we're only going to traverse n nodes. And the reason why I'm saying this, or I guess technically n plus 1 nodes, because, so let's go over this example. We start at 3, so that's one node. We go to 2, that's another node. We go to 0, that's another node. We go to -4, that's another node. And finally we go back to 2. And then when we get to 2, that's 5 nodes we've traversed so far. And when we're currently at 2, we see that this node is already in the list set, so we can return true in this case. So in this case, if the input size was n, which is 4, we've traversed n plus 1 times, which is why I'm saying that it's linear. But if there's no what's it called? If there's no cycle, like in this case, we're just going to traverse n times, because we eventually exit the loop at some point when we reach the end of the list. But yeah, and as for space complexity, it's the same thing. It's going to be linear, and the reason why is we need to store n elements in this list set. So yeah, that's my solution for the day.